Recently, there's been a surge in discussions about massive cosmic objects that could potentially be heading our way, and some of the headlines are straight out of a science fiction thriller. NASA has made a series of eye-popping announcements regarding some gigantic space wanderers that could be on a course toward Earth in the near future. This has sparked some serious chatter, with people wondering if we're facing an impending cosmic disaster, or if this is just another sensationalized scare. Imagine citywide destruction, seismic shockwaves rocking the planet, and the global scramble to protect infrastructure. Could this be a modern-day doomsday scenario, or just a brief moment of panic? Let's explore the science behind NASA's unsettling 2025 forecast and find out what's really happening out there in the vastness of space. Apophis, the asteroid with a reputation for being unlucky, one of the most infamous near-Earth asteroids in recent years, is Apophis. This asteroid made headlines when it was first discovered back in 2004 by astronomers at the Kitt Peak National Observatory in Arizona. At the time, scientists realized that Apophis, though a long way off, had a very slight chance of crashing into Earth sometime in the distant future. While this chance was small, the mere possibility was enough to set off a frenzy of speculation and anxiety, especially after early calculations suggested that Apophis could pass extremely close to our planet on April 13, 2029, and yes, it would be a Friday, adding to the drama and fueling the unlucky asteroid moniker. People got nervous. Was Earth really at risk? The fear grew as more observations were made, and people began to wonder if we were about to witness the beginning of a catastrophic event. But as astronomers continued to refine their understanding of Apophis' orbit, they realized that the asteroid wouldn't pose a serious threat after all. Subsequent observations helped narrow down its path with greater precision, and by 2021, NASA had confirmed that Apophis wouldn't collide with Earth for at least another century. Phew, right. Despite the relief, Apophis still holds the attention of scientists, particularly because of a phenomenon called the Yarkovsky effect. This refers to the way an asteroid's orbit can change slightly over time due to the way it absorbs and re-emits solar radiation. When an asteroid like Apophis heats up on one side and radiates that heat away, it gets a tiny nudge in the opposite direction. These tiny shifts can add up over the course of years or even decades, nudging an asteroid off its predicted path. So, astronomers continue to monitor Apophis carefully to keep the potential risks in check. Apophis flyby in 2029 will be an exciting event, though. It will pass so close to Earth that people might even be able to see it with the naked eye, and scientists are eagerly planning to observe it. They hope to learn more about its composition, rotation, and any changes to its surface caused by Earth's gravity, making this flyby a valuable opportunity for planetary science. Gamma-ray bursts, the cosmic threat that could obliterate life as we know it. Next up, let's talk about gamma-ray bursts, GRBs, some of the most powerful and energetic explosions known in the universe. GRBs are the rock stars of cosmic phenomena, and their brief but incredibly intense bursts of energy are capable of outshining entire galaxies for a fleeting moment. In just a few seconds or minutes, these bursts release more energy than the Sun will produce in its entire lifetime. Why should we care about GRBs? Well, if one of these bursts happened to be pointed directly at Earth and was close enough, it could cause some catastrophic effects. The intense gamma radiation emitted from the burst could strip away Earth's ozone layer, which acts as our planet's shield against harmful ultraviolet, UV, radiation. Without the ozone layer, UV radiation would flood the Earth's surface, wreaking havoc on ecosystems, drastically increasing cancer rates, and possibly causing widespread damage to life on the planet. In addition to damaging the ozone layer, a powerful GRB could also trigger the good news. The odds of a GRB happening close enough to Earth, and being pointed directly at us, are incredibly low. The universe is vast, and the geometry and timing of such an event would have to be perfect for it to pose any real threat. Space telescopes like NASA's Fermi Gamma Ray Space Telescope and the Neil Gearhart Swift Observatory are constantly on the lookout for these cosmic explosions. They track the bursts as they happen and follow up with observations in other wavelengths of light, like X-rays and radio waves, to build a full picture of what's going on during these intense events. While the odds of a GRB affecting Earth are slim, the consequences of such an event would be devastating. It's just one of those cosmic hazards that we have to keep an eye on, no matter how unlikely it is to happen. SN 1987A, a supernova explosion that changed everything. Supernovae, the spectacular deaths of massive stars, are some of the most awe-inspiring events in the universe, and one of the most significant ones we've observed firsthand is SN 1987A. This supernova exploded in 1987 in the Large Magellanic Cloud, a satellite galaxy to our Milky Way. That's close enough to observe in detail, especially by astronomical standards. Supernovae occur when stars, many times the size of our Sun, run out of nuclear fuel. Without that internal pressure to fight off gravity, the star's core collapses, setting off an explosion that can send material flying into space at mind-boggling speeds. When SN 1987A exploded, it was so bright that it was visible to the naked eye, even though it was in a neighboring galaxy. It was the first time in human history that astronomers got to witness such an event in real time. The explosion provided a wealth of data for scientists. Not only did they observe the light from the explosion, but they also detected neutrinos, tiny particles that were emitted from the supernova. This was a huge breakthrough, because it confirmed long-standing theories about what happens inside a star at the moment of its collapse. The debris from SN 1987A has formed a beautiful glowing ring, which we continue to study today. Each observation of this debris helps us understand how supernovae influence the universe, and how they seed space with the elements necessary for the formation of planets, stars, and even life itself. The rogue black hole, a cosmic wild card on the loose. Let's shift gears to a more ominous and mysterious topic, rogue black holes. A rogue black hole is exactly what it sounds like, a black hole that's floating through space without being anchored to any galaxy or star system. Black holes are typically found at the centers of galaxies or form when a massive star collapses. But rogue black holes have been ejected from their homes, often due to dramatic events like galaxy collisions or the merger of two black holes that sends the resulting black hole flying into intergalactic space. If a rogue black hole were to pass near our solar system, its immense gravitational pull could cause massive disruption. It could throw planets off their orbits, or even tear them apart. If the rogue black hole stuck around, it could begin to feed on matter from nearby stars, creating a hot, glowing accretion disk that emits intense radiation. This radiation could be harmful to any planets nearby, possibly even frying them. In 2022, astronomers made a groundbreaking discovery using the Hubble Space Telescope, when they detected what they believe to be the first isolated stellar black hole. This black hole is about 7 times the mass of our Sun and is moving rapidly through space. While it's not anywhere near our solar system, the discovery has prompted scientists to pay more attention to rogue black holes and their potential impact on our galaxy. Fortunately, the odds of a rogue black hole drifting into our solar system are astronomically low, but it's a risk that scientists continue to monitor. If one were to come close, we'd likely see warning signs, as it would affect the orbits of the outer planets first. But even with advanced notice,